Hi, good evening. I'm recording this video as a demo for the system, for the simulation that I built of this uh, real-time processing pipeline described in this assignment. So I'll directly go to the code. I have uploaded it in GitHub. I'll be sharing this link along with this video for review. So I'll just quickly go through the structure of the project. So I have as part of this assignment, I was just doing it over the weekend quickly. So I focused mostly on solving the problem, not necessarily uh, writing the best structural codes in terms of error handling and other optimizations. But my focus was getting the job done as described in the problem statement, and also using a local development environment within my laptop. So primarily, these are the three main packages that I have used for this project. One is local stack, which basically is simulating a local AWS development environment, and Kinesis is part of it. So it kind of provides Kinesis on my local laptop. I have used Boto 3, which is an AWS SDK for Python. This is to interact with the Kinesis streams from Python, as well as the Faker Python package to generate the fake order data. So in terms of the project structure, there are majorly four scripts. So there is a reset script that basically deletes and recreates the necessary Kinesis streams, sets up the test environment. The order generated.py is the file that generates the fake orders. This is basically the producer that inserts the event order created. Order assignment.py is the primary consumer. So any order that has been created and is in the queue order created gets picked up by this script, and a driver name is assigned to against that order ID, and then that event is stored as part of order assigned. So this is basically the primary consumer. There is also a order completed. This is one more consumer which actually reads all the assigned order and then marks it completed. I've just put some random business logic to compare when the order was assigned and after a certain time only to start marking it as complete. I've also given all the installation and setups that are needed before you can run the scripts, and example of how the different scripts needs to be run, right? So one more script I didn't mention here, and I'll probably add it later. It's this viewstream.py, which is basically just a small code to quickly inspect any of the streams that we are creating as part of the producers or even within some of the consumers. Apart from that, uh, we also have a notebook here, which basically, and I'll show this notebook also as part of this demo, which basically shows all the, let me just put this aside, shows one of the metrics that was being asked to compute, which is the top regions. Unfortunately, I didn't get the time to get to the bonus metrics calculations, but I will do it over some time, maybe by tomorrow or so. Okay, now going to the demo itself. So yeah, this is just to show that I have local stack running as Docker, and as you can see, Kinesis is running as part of my port 4568. So what I've done is I've just opened 6 instances of terminal to show parallelly. This obviously can be done in many different ways, but I just have the scripts individually. So on the left column, these 3 panes actually shows the 3 separate scripts: order generation, the producer; order assignment, the consumer, assignment consumer; and order completed, the completion consumer. Then I'm calling the same view stream script with just changing the parameters, order created, order assigned, order the name of the different streams to look at the records. Now, if you see the order generated PY that accepts two parameters, the name of the stream, I also pass a number there. This is just to make sure that the script doesn't run forever. So it will run how many minutes it should run. So this will run for 2 minutes and will generate orders in batches. And this also handles at least 10 orders within a second. Similarly, order assignment also accepts two stream names, which stream to read from and which stream to write to. Again, this also has accepts a parameter, numeric parameter. This is again just to ensure that it doesn't always wait infinitely, but rather comes out of the loop if there is nothing to assign after 2 minutes. Similarly, for order completed also, it accepts two stream names from the stream that it should read, which is the assigned or order assigned, and then put the order ID on the order completed. And then again, same numeric parameter. Here also, it based on this parameter, it kind of sees if the assigned order timestamp is at least certain amount, half of this. I have just put some random business logic, like half of this number, the difference between the current time and the assigned time will be at least 1 minute before it gets marked as completed. That can be put, the real business logic can be put depending on this will not be actually batch marking. It will be more of as and when the trip completes, it has to be marked as completed. But here, just to simulate the different queues, I have put this arbitrary business logics. And then on the right side, I have this view streams. This is just, I'll execute this to show that the different records that are coming. So now what I'll do is I'll just go ahead and start executing this, starting from generator, then I'll move to assignment, and then to the completed one. So what it does is it basically starts with a batch of 15, and then it basically kind of monitors a little bit around 1, and based on that it can adjust the batch size. It will keep on going incrementally. If it crosses 1, then again it reduces the batch size to keep it every batch less than 1 second, and also it kind of handles if the batch size becomes less than 10, then it will error out. Again, I haven't handled like throwing messages, error messages, or throwing exceptions that much in the scripts, but that can be easily done. And here, as you can see, it has started generating. And if you look at the data column, so it's already giving, I have also put some business timestamp as part of the data. It has shipped to region, order ID, price, pickup times, ship from region, etc. And I have used a partition of the region. Okay, now let's start assigning the orders as well as view the. So on the order assignment, again, it takes a batch of 15. Here I'm not varying the batch. It just basically takes the 15 as a static batch and starts assigning them one by one. And if you look at the data here, so it has an order ID and a driver. Again, in both these cases, both for the order generation and for the driver name here in the order assignment, I have used Faker to generate the values. Okay, now let's try to start marking some orders as completed, right? And similarly, so it says it still has 15 seconds left before it reaches that minimum threshold, and then basically it will start marking it as complete. Okay, so it's started marking it as complete, and you can see those streams here. What it does is it just puts the order ID as part of this event. If you see, the generation has stopped because I have put 2 minutes as the threshold, and after 159.93 it stopped inserting, whereas rest of these are going. Okay, so while this continues to run, both the assignment and the completion, let me show you the notebook. So this is a notebook for the top n region analysis. This basically is reading from the order created stream and then counting the number of orders by region, and then picking up the top 10 regions. I have defined the parameters here. So let me just execute. So yeah, so top 10 parameters are region 69 region, and these are all faker generated values. I have used 0 to 99 as the limit, so there can be 100 regions. So region 69 has 32 orders, region 17 has 30 orders, so on and so forth. That's kind of the entire project, and as I said, if need be, I can do the bonus part also sometime tomorrow. But before our meeting tomorrow, I just wanted to make sure that I have uh, recorded this demo video and uploaded the code files done so far on GitHub. I'll be sending these details over email. Thank you so much.